Hi guys, in the last video we have discussed exercise 3.2 and also we have finished that exercise, that is exercise 3.2. So in this video we shall discuss exercise 3.3. So first of all, first problem, we have 6 bits totally. So we shall discuss 3 bits in this video and another 3 bits in the next video. So starting the first problem, find the zeros of the following quadratic polynomial and verify the relationship between the zeros and the coefficients. So we'll discuss a new topic in this exercise. So we have to find the zeros of the quadratic polynomial. They have given the given polynomials are quadratic, so we have to find the zeros and we should verify the relationship between the zeros and the coefficients. So first of all, first bit, x square minus 2x minus 8. So this is quadratic equation as they have said. So we'll think p of x is equals to 0. That is the general formula. So we'll think like that. So the given polynomial is x square minus 2x minus 8 is equals to 0. We'll think like that. So when we simplify a polynomial, we'll multiply this first and last digits. So when we multiply 8 into x square, we'll get 8x square. So if we 8x square can be multiplied as 2x minus 4x, 2x into minus 4x. So we'll get minus 2x. So minus 2 plus 2 minus 4 means we'll get minus 2x. So we should get this term when we multiply this term. So we'll get x square plus 2x minus 4x minus 8 is equals to 0. In the place of minus 2x, we'll write plus 2x minus 4x. So when we take out common from this, so x square, that is x into x, x square, x into 2, 2x. So we got this term, and coming to this term, if we take out common, we'll get minus 4. So minus 4 of minus 4 into x is minus 4x. So minus 4 into plus 2 is minus 8. So we also got this term. So when we take out common, so we'll get x minus 4 of x minus 2. So x plus 2. So x plus 2 into x minus 4 is equals to 0. So when we simplify this, x plus 2 is equals to 0. We have thought that p of x equals to 0. So when we simplify that, x plus 2 is equals to 0. Therefore x equals to minus 2 when we transfer to this side. So coming to this term, so x minus 4 is equals to 0, then x is equals to 4. As minus 4 comes to RHS, it will become 4. So the zeros of the polynomial x square minus 2x minus 8 is minus 2 and 4. Therefore hence minus 2 and 4 are the zeros of the polynomial x square minus 2x minus 8. So coming to the relationship between the zeros and the coefficient. So first of all, we'll see here sum of zeros and we'll verify that, and we'll also see the product of the zeros and we'll verify that product of the zeros. So if we see that, we'll get the relationship of between the zeros and the coefficients. So first of all, sum of zeros, that is zeros are minus 2 plus 4. So minus 2 plus 4 means is equals to 2. The answer is 2. So sum of zeros, they have a formula, that is minus coefficient of x by coefficient of x square. So minus coefficient of x means we have the coefficient of x is minus 2. So in the place of coefficient of x, we should write minus 2. Coefficient of x square means we have nothing, so we will write 1. So in the place of minus coefficient of x, we got minus 2x. So minus 2 and minus before we have, so as it is, by coefficient of x square means 1. So 1. So minus into minus plus. So 2 by 1 means 2 is the answer. So we got verified this sum of the zeros, and by using the formula we got verified as 2 is the answer for both. So when we come to the product of the zeros, minus 2 into 4 is equals to minus 8. Minus 2 into 4 means minus 8. So the product of zeros, we have the another formula, that is constant term by coefficient of x square. So constant term is, here we got minus 8, and coefficient of x square is, we already discussed here, it is 1. So minus 8 by 1 is minus 8. So here it is proved from the product of zeros, and we when use the formula we got the same answer. So the relationship between these two are verified. So coming to the second bit, 4s square minus 4s plus 1. So we'll think first of all it is as p of x is equals to 0. So when we write this, 4s square minus 4s plus 1 equals to 0. So 4s square, so minus 4s can be written as this minus 2s into minus 2s, that is 4s square into 1 is 4s square. So 4s square can be written as minus 2s into minus 2s is 4s square. So in the place of minus 4s square, we'll write 4s square minus 2s plus 1 is equals to 0. So when we take out the common, we'll get 2s into 2s, that is 4s square, and 2s into minus 1 is minus 2s. So when we take out common from this term, we'll get minus 1. So minus 1 is the common from this term. So minus 1 into 2s is minus 2s. So minus 1 into minus 1 is plus 1. So is equals to 0. So 2s minus 1 and 2s minus 1 are the two terms. When we transfer this, we'll get 2s is equals to 1 and s equals to 1 by 2. Hence, therefore, 1 by 2 and 1 by 2 are the zeros of the polynomial 4s square minus 4s plus 1. So we have to find the relationship between the zeros and the coefficients. So as I said, we have the formula, and also by using the sum of zeros we'll get the verified. So sum of zeros is equals to 1 by 2 plus 1 by 2. We got the answers zeros as 1 by 2 plus 1 by 2. So 1 by 2 plus 1 by 2 is 1. How? 1 here, 1 plus 1 by 2. It is a like fraction, so we can write 1 plus 1 by 2, that is we get 2 by 2 is equals to 1. So from this we will get 1. So sum of the zeros, by formula we can write minus coefficient of x by coefficient of x square. Minus coefficient of x means in the question minus coefficient of s, so minus 4, and minus into here the coefficient of is minus 4, so we have to write minus as it is. So minus into minus plus by coefficient of x square is also 4, so equals to 4 by 4 means 1 is the answer. So we'll see the product of zeros. 1 by 2 into 1 by 2 means 1 by 4. So here 1 into 1 means 1 and 2 into 2 is 4. So product of zeros by formula we are using. So constant term by coefficient of x square. Constant term means 1 and coefficient of x square is 4. So as we see in the problem. Therefore, this product of zeros also verified. So therefore, hence proved the relationship between the zeros and the coefficients. So coming to the third bit, 6x square minus 3x minus 7x. So we'll think p of x is equals to 0. So 6x square minus 7x minus 3 is equals to 0, we'll think. So minus 7x can be written as 6x square into minus 3. So 6 3s are 18. So 18x square, that is minus 9x into 2x. So we can write the 7x. Minus 9x plus 2x means minus 7x. So we can write in the place of minus 7x minus 9x plus 2x. So when we take out the common from this, we'll get 3x into 2x is 6x square and 3x into minus 3 is minus 9x. So we have taken common out from this term. So when we take common from this term, we'll get minus 1 into 2x, that is minus 2x. So minus into plus is minus plus 2x. So minus 1 into minus 3 means minus 3 is equals to 0. So we have taken out the common, that is 2x minus 3 and 3x minus 1. So when we take out the zeros, we'll get 2x minus 3 is equals to 0. So 2x is equals to 3. When this minus 3 gets transfers to RHS, it gets 3. So x is equals to 3 by 2. So this 3x plus 1 is equals to 0. 3x plus 1 is equals to 0 means when we transpose this into RHS, it will get minus 1 and x. So 3 transfers to this side means it is multiplying here, it will be dividing here. So hence the zeros of the polynomials are 3 by 2 and minus 1 by 3 are the zeros of the polynomial x square minus 7x plus 3. So now we will see the relationship between the zeros and the coefficient as given in the problem. So sum of zeros, first of all we will take sum of zeros. 3 by 2 plus of minus 1 by 3, plus into minus minus, so I have written directly here. 7 by 6, when we do the LCM we will get 7 by 6. So sum of zeros by formula, so minus into coefficient of x. So coefficient of x in the formula is coefficient of x. So minus 7 is the coefficient of x and coefficient of x square is 6. So minus into minus plus, so 7 by 6. We got the answer 7 by 6 and hence proved in the sum of zeros. So when we see in the product of zeros, 3 by 2 into minus 1 by 3 is equals to minus 1 by 2. So if we see here product of zeros by formula, so constant term by coefficient of x square. Constant term means minus 3. As we see in the problem, minus 3 is the constant term and coefficient of x square, that is 6, is equals to minus 1 by 2. Here 3 ones are 3 twos are 6, so minus 1 by 2 is the answer. Hence it is proved in the product of zeros. So that's it guys. So we have also proved that zero relationship between the zeros and the coefficients. So in this video that's it. In the next video we shall discuss 4th, 5th, 6th bits in this problem 1. So see you in the next video guys.